Good morning, dear students. Today we are having the 14th practical lesson of advanced calculus, and this lesson is about differential equations of higher order that allow for reduction of order. And first of all, let's solve first. Let's start with solving first task. Actually, yeah, what is the order of the differential equation? It is the higher order of the derivative that it contains. Now we're having the differential equation of the third order. So y 3 prime equals 1 over x. Actually, how to solve it? Of course, we will integrate this equation three times. So y 2 primes will be equal logarithm of module x plus c1. By the way, number of arbitrary constants must be equal to order of the differential equations, of the order of the differential equation. So now if we have third order, there will be three arbitrary constants. So continuing, then y prime. Okay, yeah, we actually can now even well, yeah. Let we not remove the module for now. So y prime will be equal. So we will have to integrate this module. Yeah. Now let we integrate by parts, first of all. So u equals dx. U equals logarithm of module x. Du equals dx over x. Then dv equals dx and v equals x. So x logarithm of module x plus plus integral over dx. So y prime will be equal x logarithm x plus x plus c 1 x plus c 2. And now we need to integrate this differential equation once more. So which integral is most interesting for us? Actually, this integral. So we will integrate x logarithm of x. So u equals, so the same actually, logarithm of x, module x, du equals dx over x. Then dv equals x dx, and v equals 1 over 2 x square. So u equals 1 over 2 x square logarithm of module x minus integral minus stop minus here, by the way. So uh, okay, so fixing this mistake. So now everything is correct here. Yeah, and here minus 1/2 integral x of x dx. Stop, minus 1/2 x square. So the final answer, so the general solution will be the following. So this integral minus, yeah, by the way, so this x will be okay. Let me write in details now, and after that I will simplify. Plus C1x square. Yeah, paying your attention that here I don't use 1/2, but actually, yeah, okay, what we better use it just for more understanding. But this is an arbitrary constant, and it will be found with using. So it will be found if you have initial conditions. Okay, and now let's simplify it a little bit. So minus 3/4 x square. Actually, that's enough. We of course can use we can move x square out of brackets, but this answer is acceptable. Any questions about this exercise?
No question.
1/2 before the constant. It's because we integrate v is 1/2 and
So we have C1x. So integrating x and receiving 1/2 x square.
thank you.
Yeah, so we calculate the integral for the whole right part here, but actually what is the most complicated, this integral of x logarithm x.
I understand, thank you.
More questions? Okay, if no questions, let's move next. So exercise B is analogical, even easier. So let we move to 1C. So here you will have to integrate 2 times. So let's do the following substitution. Yeah, first of all, writing down the equation. Plus y prime square plus 1 equals 0. So in this equation, we actually can so we can reduce the order of this equation. We see that there is no zero order, so we have derivatives of the first and the second order. So we can do the substitution. So p will be function y prime. So function p will be y prime, and p actually uh, depends on x. So then y 2 prime equals p prime. So the equation will be rewritten in the following form. 1 plus x square p prime plus p square equals 0. Actually, we received the equation with separable variables. So let's separate variables and integrate. So dp by dx equals minus p square. Then continuing separating variables, so dp by p square equals minus dx over 1 plus x square. So let we now integrate both parts. What do we receive? Minus 1 over p equals minus arctangents x plus c1. Yeah, so we remember that we solve initial equation with respect to y. So now finding p from this equation. So dividing by both parts or multiplying by minus 1. P equals 1 over arctangents x minus c1. Then actually y prime equals arctangents x minus c1. So y will be equal integral of this expression. So yeah, this is quite it's not really easy. Oh, stop. It seems that I forgot 1. So it was a mistake here, by the way. So it was a mistake. So we restarting solving. So 1 plus x square. Here dp by dx, and it will be equal minus p square plus 1. Now now everything is correct, so we can separate variables and what we will actually receive. So dp over p square plus 1 equals minus dx over x square plus 1. And now we will integrate both parts. Okay, so what we have? Arctangents of p equals arctangents x plus c1. Then p equals tangents from the following expression. So arctangents x plus c1. So actually, now we substitute y prime instead of p. And y will be equal integral of this expression. Okay. So actually, what can, yeah, I don't really remember formula of tangents. Tangents of the sum. Yeah, and by the way, here minus arctangents, minus, and here minus as well. Okay, so tangents of difference. If I believe this recording, so it will be the following expression. So tangents C1 plus tangents over arctangents X. And 1 plus tangents C1 multiplied by tangents over arctangents X. Actually, this expression will be replaced to X. So yeah, let's simplify this integral a little bit. So here X, and here X as well. So actually, yeah, so having the following integral, and this is a rational fraction. So tangents C1, it is just a constant. So let we rewrite it as first of all, as split it to the sum of integrals. So the first integral will be equal logarithm of module of this expression. Then, okay, what about the second integral? Let we calculate it separately. Stop, X here. So let we first of all multiply and divide by tangents of C1. And then add 1 and subtract 1. So yeah, the equality is not broken. Stop. Just a moment. Yeah, not broken. Okay. So what I receive here. Yeah, by the way, this is product. So we receive integral of the, so of dx here, minus 1 over tangents of C1, integral of 1 over this expression. So what I have? So 1 over tangents Cx minus 1 over tangents C1 logarithm over this expression in the denominator. Yeah, so actually I can subtract this expression. Subtract or add this expression and I will also add constant C2. So because we found the initial function that we had to find, so that's it. We also can simplify it a little bit, but yeah, so simplify this logarithm, but I'm not really sure if we have to do it now. So leaving this equation in such a form, it is acceptable. Any questions about this exercise?
No.
No questions.
Okay, if no questions, let's move next. Okay, by the way, let me see how many tasks we have to do today. Okay, so now let's move to part D, having more practice. 1D. Yeah, we have enough time. So x, y, 2 primes equals y prime logarithm over y prime over x. So again, we do the substitution. Y prime equals p, and then y 2 primes equals p prime. And let's rewrite the initial equation. So xp prime equals y equals p logarithm over uh, p over x. And by the way, as we remember from the previous lesson, this is the homogeneous equation. So if I divide both parts by x, I will receive so p prime equals p p over x logarithm of p over x. So let's do the substitution. P over x equals u. Then u equals p equals ux, and p prime equals u prime x plus u. So writing down the equation, so du by dx multiplied by x plus u equals u logarithm of u. So now we will separate variables and calculate and integrate this equation. So du over x dx, du by dx multiplied by x equals so this expression minus u. Then so what I have next, so du over this expression u logarithm u minus u equals dx over x. Okay, so now we'll calculate these integrals. Yeah, it's not so simple, really. Okay, so let us think how to solve it. And first of all, check for mistakes. Yeah, but actually, as I see, there are no mistakes. So everything is correct. Okay. So let we first of all calculate this integral. The logarithm of x plus logarithm over c1. So done with it. Then what about this integral? Yeah, it will be more interesting. Yeah, by the way, let me put integrals here. Okay, now let we try to split it by two integrals, or by two fractions. So actually, yeah, how it can be rewritten. So u by logarithm of u minus 1. So maybe it will be simplified a little bit. Yeah, and so actually, yeah, I will move u out of brackets, and then I will receive here a simplified variant. So yeah, it's so now it's quite obvious. So logarithm of this expression actually equals du by u. So yeah, it really this integral is really simple, but it is simpler that we think before. So what I have here, so the following integral. So I will receive logarithm of logarithm. Yeah, it is so easy, yeah, so convenient, but nevertheless. Yeah, so we will have to get rid of logarithm 2 times. So what we receive? So the following equality, and now we will continue. We'll start simplifying it. So first of all, this logarithm of u minus 1 equals c1x. So remembering a rule of the sum of logarithms, then logarithm u equals c1x plus 1. Then u equals exponent of c1x plus 1. Remembering that u equals p over x. So p over x equals this expression, so this exponent. Then p will be equal x multiplied by exponent. And now returning to variable y, so y prime equals this expression. And how to find y? Just to integrate this x multiplied by exponent. So let's start, let's integrate it. So integrating by parts. So u equals x, du equals dx. Yeah, was dx here. Now everything is okay. So dv equals e in power of c1 x plus 1 dx. Then v equals 1 over c1 exponent. So 1 over c x by exponent minus integral So 1 over c e in power of c 1 x plus 1 dx. No. Incorrect hotkey. Minus 1 over c 1 square e in power of c1 x plus 1 and plus c2. So what we simplified a little bit. So I will move 1 over c and this exponent. So yeah, out of brackets. So x minus 1 over c and plus c2. Well, yeah, here 1 over c1. So the final answer, so the generic solution is the following. The following expression. So found it. Any questions about this exercise?
Can you scroll up?
Yeah, to which moment?
Up to yes, this moment.
Yeah, which questions do you have?
I'm just see. Yeah, no questions.
Okay, if no questions, yeah, maybe anybody else has questions. Okay, if no
No
questions, let's move next. So 1e. 1 plus y prime square equals 2y 2 primes. So actually here we have one more interesting case. As we can see that here we have all derivatives of y, so 0 derivative first, second, so actually whole orders we have in this equation. So we will do, so now we will do the following substitution. We will substitute, so we will use parameter p, but it will be function p that depends on y. Yeah, a p prime is a function p that y prime is a function that depends on y. So y prime twice will be equal. So we have to differentiate this p. So dp by dy and multiplied by dp by dy over dx. Stop. Yeah, actually, yeah, correct. And by the way, it will be equal also, yeah, so we will simplify this dy by dx, so it will be equal p multiplied by dp by dy. So now we have the following equation. So 1 plus p square.
But why by dy, but not dx?
P is so here we use p as a function that depends on y. So this is such case. So when we have all orders of derivatives, so we use such substitution.
I mean, in the second derivative of y, we can cancel 2 dy's and dx leaves.
No, we need to transform the initial equation to equation with variables p and y. So if I use also x, yeah, so what to do with y? So I will have three variables in this equation, and it will be even more complicated to solve.
Yeah, I understand. Thank you.
So reducing the order. So and I have two p multiplied by p by dp by dy. So I have two variables here, p and y. So this is the equation with the separable variables with respect to, so with the separable variables p and y. So no x, only two variables. And it is convenient to solve. So now that we simplify it a little bit, and after that we'll start um, we'll start separating variables. So what I actually have here, so 1 plus p square, so dy equals 2 p square dp over 1 plus p square. So of course we will integrate both parts. Of course this integral will be equal y. And what about this integral? So yeah, we'll need to simplify it a little bit. So p plus 1 minus 1. So we will have following integrals. So here will be 1 and minus 1 minus 1 over 1 plus p squared dp. So I receive p plus minus arctangents over p. So yeah, let me check how it. Let me check e here. Yeah, so stop. Yeah, it was a mistake here actually. Just a moment. Yeah, so 2. So let me check the initial equation and check where do we have a mistake. 2y. Yeah, so I made a mistake here. So yeah, I just thought that we had y prime. So this expression. So yeah, we will have, yeah, so it will be simplified. Yeah, so 2yp here. So here dy over y, and here p in power of 2. So this is, it will be logarithm. And logarithm of C1, of module C1. And this integral will be very simple. So it will be equal logarithm of 1 plus p square. Let me check. Mhm. Yeah, here is correct. So let we move next. Yeah, let we simplify this expression and what we will receive. So C1y equals 1 plus p square. Then what do we actually have? So we will have so substitute in so substituting y prime instead of p. And now we can, yeah, so we will separate variables. So y prime will be equal plus minus square root of C1 y minus 1. So next, yeah, separating variables. So dy by dx equals this expression. Then dy by this square root equals plus minus dx. And now we can integrate these expressions. So x plus c2. And this integral will be equal 1 over 2 c1 and this square root c1y minus 1. Stop. I divide by it 1 over 2, so 2 over c1. So now everything is correct. So the answer will be the following. Yeah, plus minus x plus c2, and I also can even express y explicitly here. But let we not waste the time for arithmetics. Yeah, but it will be a good idea to extract y because we can do it. And let we see what received in these materials. Yeah, so such answer and y can be expressed explicitly, but yeah, not here, not now. Any questions about this exercise?
No questions.
No questions. Okay. Let we have one more. Let we have some more practice. Let's solve one exercise, and after that we will have a break. So to complete the logical part, and after that we will solve Cauchy problems. So y prime plus 2 over 1 minus y, y prime square equals 0. So again, Here we have all orders of derivatives, so we will use the substitution p equals p from y. Actually, yeah, y prime. So y prime is a function p that depends on y. Then y prime equals dp by dy multiplied by dy by dx. So it will be equal p by dp by dy. So substituting everything that we received into the initial equation. So 2p square 1 minus y equals 0. And now let's start separating variables. So moving this part to the right, and I will change the sign here. So y minus 1, yeah. So actually it will be equal. Then what I also can do, I can cancel p. And after that, I receive, what I receive, dp by p equals to dy by y minus 1. And let's integrate. So logarithm of module p equals 1/2 logarithm of module y minus 1 plus logarithm of module c1. So then p will be equal c1 by square root of y minus 1. And now let's remember that p is a variable, so that p is a derivative of y. So let's substitute dy over dx equals this expression. So now we can easily integrate. So this exercise is even simpler than the previous one. So dy over c square root of y minus 1 equals dx. So let us integrate this equation. So this integral will be equal x plus c2. And what about this integral? So it will be equal 2 over c1 square root of 1 minus 1. So we will receive the following equality. And yeah, by the way, what we even now extract y. So what I will have, so this square root equals c 1 over 2 x plus x plus c 2. Then y minus 1 equals so c 1 square over 4 x plus c 1 square. And finally, yeah, so what we will receive, so y equals so this expression minus 1. So this is the final answer, general solution. Any questions about this exercise?
No.
Okay, no questions. So now let's have a break for 5 minutes, and after that we will solve Cauchy problems for higher order equations. Let's continue. So we have the following exercise. So we need to find partial solutions of the specified differential equations under given initial conditions. So the first equation is the following. So y2 primes equals y prime over x plus x square over y prime. So first of all, so how can we actually solve this equation? Yeah, by the way, what about the initial conditions? So y from 2 equals 0 and y prime from 2 equals 4. Yeah, pay your attention that so the number of initial conditions must be, so always must be equal to the order of the equation. So if the if missing conditions or so if they're not equal, it means that some mistake in the task requirements. So always so number of initial conditions equals the order of the differential equation. And now let's first of all solve the differential equation. As we can see that we have no, so this equation doesn't contain function y, it contains only derivatives. So we will use the following substitution. So y prime will be equal p, and p is a function from x. And then y2 primes equals p prime. So p prime will be equal the following. So now doing the substitution, so p over x plus x square over p. So received the following equation. Okay, and it will be the equation with so it seems to be the equation with separable variables. Let's separate them. And I will write here dp by dx. So let's separate variables. How to do it? We'll find the common denominator for the right part. So px, yeah, I hope it will help. So p square plus x stop. Yeah, plus x cube. And I'm not sure that it really helps. Yeah, it really doesn't help. And by the way, if I'm not mistaken, we also can try to use yeah, here it is yeah, so incorrect way. I forgot really. Yeah, let's pay the attention that we have the Bernoulli's equation. So here the power of 1 for the derivative, power 1 for function p, and power -1 for function p here. So actually it could be any power but -1. So we will use Bernoulli's method to find the solution of this Bernoulli's equation. So P will be equal UV, then P prime equals u prime v plus uv prime. So writing down the equation. So uv over x plus x square over uv. Let me move then so uv over x into the left part. So now I will extract, so I will move out of brackets u, so here. So u prime v plus u v prime minus v over x, and equals x square over uv. So actually, the idea of the Bernoulli's method that so we yeah, just reminding you so that I consider that the function is a product of functions u and v, and then I so here extract u, and I suppose that this part equals 0. And if this expression equals 0, it means that u prime v equals x square uv over uv. So now finding v. So dv by dx equals v over x. Then dv by v equals dx by x. So logarithm of v equals the logarithm of x, of module x, and then we can write down that v equals x. So let me check here. Yeah, so v equals x. Nice. Then I will substitute x instead of v into this equation. So what I will receive? U prime x equals here x square by ux. So first of all, canceling x here, and then I will receive that du by dx equals 1 over u. So u du equals x. Yeah, forgot I was dx here. So received that 1 over 2 u square equals x plus c1. Then u equals plus minus square root of 2x plus c1. Then p will be equal the following expression. So plus minus x and this square root. And actually, it is y prime. Let me check if everything. Yeah, correct. Yeah, here lost plus minus, but yeah. So let's now let's solve. Let's continue solving. Yeah. So now I suggest to find the constant c. Yeah, and if so, we have yeah. So x equals 2. Yeah, and by the way, let's yeah, let's go like this. So yeah, let's suppose that we have only positive root. So now let's find the constant c1. Of course, I can integrate this equation once more, and after that find c1 and c2 from the system of linear algebraic equations, but I can find c1 now. So y prime from 2 equals 4. So let we substitute. So 4 equals 2, and here 2, and multiplied by 2 plus c1. So what I actually have here, so 4 plus c1. And from this equation, we can see that c1 equals 0. Stanislav, yeah, question?
Shouldn't it be 4 plus 2c1?
By the way, yeah, 4 plus 2 c1, but anyway, c1 equals 0. Yeah, but nice catch, thanks. Okay. Stop here. C1 equals stop. So, y, yeah, so it was a mistake. Y prime. Yeah, so y prime from, yes, okay. So here must be 4. And to C, yeah, so it was a mistake here. Actually, yeah, that's good that we, okay, I will resave it later. So received that y prime equals x by square root of 2x. And now let's integrate. So y equals integral. Okay, let me move square root of 2 out of brackets. X square root of x dx. So it will be equal to square root of 2 over 5 x square square root of x plus c2. And now remembering, so taking into consideration this initial equation, boundary, yeah, this initial equation that y from 2 equals 0. So now substitute, so doing the following substitution. So 0 equals, so 2 square roots of 2 multiplied by 4 multiplied by square root of 2 plus C2. So what do I have here? Let's simplify a little bit. So let's find C2. So C2 equals minus this expression. And finally, C2 will be equal, so here 8, so minus 16 over 5. Minus 16 over 5. So the final answer will be, so y equals this expression minus 16 over 5. So that's it. Any questions about this exercise?
No.
No questions.
Okay, no questions. So let's move next. We'll solve one more exercise, the final exercise for today. Okay. Okay, fix it. So a reminder for now. Okay, the next equation that we have, y multiplied by y2 prime equals y prime square minus y prime cube. And y from 1 equals 1, y prime from 1 equals minus 1. So now doing the substitution that we did before, so y prime will be equal p from y. Then y 2 primes equals dp by dy multiplied by dy by dx. So it will be equal p by dp by dy. Now substituting it into the equation. So on the left, I receive yp dp by dy and equals p square minus p cube. Now we will simplify it. Yeah, so we will start separating variables. So we can cancel p from both sides. Yeah, here we'll have so p minus p square. Then so dp over p minus p square equals dy over y. And now we will integrate both parts. So what are we doing now? Yeah, so this expression, so this equation, so this integral will be equal logarithm of y Okay, plus logarithm of C1. And what about this integral? Yeah, we will use a method of undefined coefficients. So 1 over p 1 over p minus p square. So factorizing it, and I receive a over p plus b over 1 minus p. So a by 1 minus p plus b p equals so yeah, so now let's expand the brackets and regroup multipliers. So a minus ap plus bp divided by this expression, and now let's regroup. So minus a plus b p plus a. So what do we have here? That a, so minus a plus b equals 0, because we have no power of 1 for p, and for power of 0 a equals 1. So what do we have here? The following integral. So no, 1 over p plus 1 over p minus 1. Stop. Oh, yeah, by the way, b equals 1 as well. So correct. For now, again, dp. So now, calculating this integral, I will receive logarithm of module p plus logarithm of module p 1 minus p. So received the following expression. So what do we have? Now we'll simplify it. So C1y will be equal p by 1 minus p. So done with it. And then what do we actually have? Okay, let we see if we can yeah, so we need to integrate this expression once more. So we need to integrate our equation once more, and then find p. But what do we really have? So that it is really hard to find the second integral of this equation. Let me see how it is solved here. So minus 1 y minus, yeah, really minus here. So here is a mistake. Yeah, forgot about this minus before p. Then yeah, so we cannot find really the generic solution in explicit form, but what we try, so maybe one. Yeah, so actually this is quite a frequent case, but let me check. Maybe we can simplify it more a little bit. Let me see how actually it is done in different examples. By the way. Well, yeah, so actually we can also use yeah, we can write also it down in a parametric form. So actually we can go with this solution, so with this answer. It is acceptable in such cases, yeah, so it's no way to move next here, and because we received such expression. Any questions about this exercise?
No questions.
Okay, no questions. And by the way, reminding you about the competition with math. So yeah, take part. I see that you smart students. So just yeah, let me share it with you and remind. So by the way, where? Yeah. So here is the link. So yeah, take part. I remember that it is also on jail. So just reminding you. So this Saturday. Any questions about maybe this lesson, about previous lessons?
Haven't you checked our individual works number 2?
Not yet. I will start checking this week. Yeah, but of course I remember about you. Yeah, and by the way, always pay attention to comments on DL. Okay, if no more questions, we will finish. Or more questions.
No more questions.
Okay, so have a nice day. Thank you for your attention. Stay safe. Goodbye.
Thank you, goodbye.
Thank you.
Thanks
Bye.
for the lesson. Have a nice day too. Goodbye. Stay
Bye.
safe.